Hello everybody. Today we will start with a new chapter in Physics Standard 9th ICSE, that is current electricity. Now we already learned about electricity in the previous classes, 8th standard and all that, and that we learned that it's basically charge. So, and that charge was going to be present whenever there is a transfer of electrons from one object to another object, and that's why we have got to be knowing that if at all we are taking a bad conductor and I am rubbing a bad conductor with some cloth, so like for example if I take plastic and silk, glass and silk, or ebonite and fur, and then I am rubbing it, what will happen is that the electrons are going to move from one object to another object, and accordingly, because the other one is a non-conductor, that's why the electrons will be located in the same area, that is called as static electricity. But this chapter, what we are learning about is current electricity. That means current means flow. So whenever the charge is going to flow from one end of a body to another end of the body, then that particular kind of electricity is called as current electricity. So in current electricity, we see that the electric current will be produced, or we can say the generation or the source of electric current will be either a generating power station, or in small terms it will be the battery, the cell or a battery. So whether it is a small battery like a pencil cell or a button cell, or maybe a car battery. So depending upon the kind of utility what you want, there will be different kinds of batteries, and that the battery gives you a source, electrical source, which is called as direct current. Okay, it gives you a direct current which will have a constant value or constant magnitude of the voltage and current. So voltage supplied by a battery will be a direct current, whereas the one which is supplied by the source, को हम लोग का जो plug point होता है, वो जो है, that is called as alternating current. So it is alternating current. Now the alternating current is the one in which the positive and negative, यानी उसका अगर हम लोग ग्राफ बनाए तो it will be, voltage will be like this. So it will be continuously positive negative करके जाएगा. That's why it has got a frequency of 50 hertz. That means it will going to become 50 times positive, 50 times negative in just 1 second. So that's called as an alternating current. So anyways, we are not learning about alternating current over here, but what we are going to learn will be about direct current. So direct current, so first thing is sources of direct current. We are familiar with cells used in the torch or light up its bulbs. So we very well know that torch के अंदर क्या होता है, एक battery होता है. We put the batteries over here and then you switch it on, so the bulb glows. So that glowing of the bulb is because of the battery which is inside, which is the source of the electric current, which is a direct current. The cells are the source of the direct current. They provide direct current, abbreviated as DC, to the bulb. The current flows from the positive terminal of the cell to its negative terminal through the bulb of the torch. The magnitude of current given by the cell remains constant for a sufficiently long time. When the cell gets discharged, it stops giving current and becomes useless. Thus, we can define the direct current as follows. Direct current is the current of constant magnitude flowing in one direction. So when the magnitude of the current is going to be constant and it is only unidirectional, it is going to one particular direction, then we call it as a direct current or DC. So this is what they are giving you, that the battery, if you connect a battery and you like torch को जब चालू रख दिया तो क्या होगा, after certain time, maybe after 1 hour, 2 hours or 3 hours, depending on what is the condition or what type of battery it is, what will happen? The bulb will slowly get dimmer, and finally it will not burn at all. So Why is it not going to glow at all? Is because the current which can be generated in the battery is getting over. That means the chemical reactions which are taking place in the battery are no longer completed, and hence it cannot be restarted. So that's why the battery gets get discharged. So when the battery gets discharged, if it is a normal battery, then you are just going to throw it away. But if it is something which is a rechargeable battery, then you can put it again to a charger and then you recharge it and put it again in the torch. Yeah, it's possible. So otherwise, normally हम क्या करते हैं? Battery खत्म हो गया, खलास हो गया, you discard it. So you can see that the in a battery it will always be this way. If I take a battery, तो battery में के अंदर it is something like this. So this over here is the anode, that is the positive terminal. This is the positive terminal anode, and this is the cathode. So anode and cathode are the positive and negative terminals of the battery. The positive, this is the positive terminal. This part जो बाहर जो आता है, that is the positive terminal, and the flat one at the bottom is the negative terminal. And current is always going to flow from the positive terminal to the, so this is the bulb, and it is going to come to the negative terminal. So current will always flow from, if I put a switch over here, it is going to go from positive to negative in this way. So this is how the current is going to flow in particular circuit. In a cell, chemical energy changes into electrical energy when it sends current in a circuit. A cell basically consists of two conducting rods called the electrodes at some separation placed immersed in a solution or jelly called the electrolyte kept in a vessel. So what is a cell? Cell is basically a chemical reaction is going to take place in a cell. So there are two electrodes, positive terminal and the negative terminal, and there will be chemical, that is the electrolyte in between. The electrolyte ke karan there will be generation of ions which is going to be there, and the generation of ions is going to lead to the generation of electrons, and not generation but the formation of the electrons, and thus giving you a particular way of movement of the electrons. So that is what is called as the electrolyte and the kept in a vessel. That is, the cell works on the principle of chemical energy converted into electrical energy. The next is kinds of cells. The cells are of two kinds, primary cell and the secondary cell. So we can say the cells are of two kinds. So the direct current is available to us by the cell, and the cell are of two kinds. So this is going to be given by the cell, and the cell is of two kinds, primary, and the next is secondary. Now the primary and cell, the cell provide current as a result of irreversible chemical reaction. So in case of primary cell, the chemical reaction which is taking place in the cell is irreversible one. That means you cannot charge the battery again. So once it is formed, you start using the thing, that means the reaction, the chemical reaction inside the battery starts, in the cells starts, and once the chemical reactions is over, the cell becomes useless. Okay, so that's kind of a one-time use and throw kind of a device. We call it as a primary cell. The cells are discarded after use when entire chemical energy in them has converted into electrical energy. Thus, they are use and throw type of cells and cannot be recharged. Depending upon the material of the electrode and electrolyte, we have different types of primary cells. Simple voltaic cells, Lechauge cells, Daniell cells, dry cells, etc. So these are certain kinds, different names of these type of cells which we are having. So simple voltaic cells, Lechauge cells, Daniell cells, dry cell. Dry cell is what you are going to use normally. The normally ever ready वगैरह जो हम लोग use करते हैं, they are called as dry cells. So that are all primary cells. So primary cells are the one where the chemical reaction is going to be only taking place once. So chemical reaction takes place, एक बार खत्म हो गया तो battery खत्म, cell is use and throw. Secondary cell or accumulators. Secondary cells also provide current as a result of chemical reaction. In these cells, chemical reaction is reversible. Sorry, not irreversible. It's a reversible, and so they can be recharged after use. So here, what happens is you have got this particular kind of a cell wherein it is going to start giving you the electrical energy when you start using the cell, and once it is over, once you can see that it is discharged, you can recharge it, you can put it to the electric current. So पहले क्या हो गया, for discharging chemical energy is going to get converted to electrical energy, and for charging the electrical energy is going to get converted to chemical energy, so that it is again ready for discharging. So accordingly you will find that electrical energy is first formed by chemical energy in case of a discharging of a battery, and for charging the battery, electrical energy is getting converted into chemical energy. So in this sense, chemical reaction is reversible, and so they are recharged after use. After taking the electrolyte and electrode in a vessel, the cell is first charged by connecting it to a direct current source. During the charging, the electrical energy changes into chemical energy and gets stored in the cell. When the cell is used to send current in the circuit, the chemical energy changes into electrical energy. These cells can thus be used for a very long period because they can be recharged again and again. Lead or acid accumulators and nickel ferrous or alkali accumulators are the two kinds of secondary cells commonly used to provide low as well as high current. So of course there are many different kinds of the secondary cells. One of these are the ones that is the nickel cadmium or nickel ferrous, and the other one is the lead acetate battery. The lead acetate battery is the one which is normally used in cars. So the big ones, the black ones, what you see in the cars, they are the lead acetate battery. Now of course we have got many. Now these ones what they told you about the nickel ferrous, uske baad mein nickel cadmium bhi aata hai, so that is all the one which are used in our mobile phones. So in the mobile phones, the batteries which they are using are secondary cells because you can charge it and recharge it, discharging ka cycles usme possible hai. So they are also the new kind of the secondary cells. And these cells, they have the capacity to give you either low current as well as high current. So if you are recall, like for example, in case of mobile phones, the current is very, very low. Whereas in case of cars, the car batteries, they require high power, high currents because it needs to ignite the petrol and all. So ignition ke liye it is required. Plus the lamps and everything are also required. So uske hisab se the car batteries are giving you more current than the other batteries. So we use lead accumulators as battery in the car as it is capable of giving high current. Low current rechargeable cells are widely used in toys and mobile phones. These cells are also called the storage cells. So we have now the differentiation between primary cells and secondary cells. Primary cell chemical reaction is irreversible, whereas in secondary cell chemical reaction is reversible. Primary, the chemical's energy is converted into electrical energy when current is drawn from it. Whereas secondary cell electrical energy is converted into chemical energy when current is passed in it. During charging, while chemical energy converts into electrical energy when current is drawn from it, that is during discharging. Primary cell, it cannot be recharged. Secondary, it can be recharged. Primary, its internal resistance is high. Secondary, the internal resistance is low. Primary, it is capable of giving weak current only, where secondary it can provide low as well as high current. Primary, it is light and cheap, whereas secondary it is heavy and costly. Examples: primary, simple voltaic cell, Lechauge cells, Daniell cell and dry cell, whereas lead or acid accumulators, nickel ferrous or alkali accumulators, and lead LiH, that is battery. So that is all about the primary and secondary cells. Now we talk about electric current. So when you talk about electric current, means what? What do you mean by electric current? So the flow, of course, the flow of electricity is electric current. So what is the flow of electricity? It is nothing but the cause due to the flow of electrons. So what is electrons? They are charged bodies. So when the charge is going to move from one point to another point in a particular time, so rate at which the charge moves is called as current. So first of all, for knowing about the current, electric current, we need to first talk about charge. So charge is given by the letter Q, and that is equal to the number of electrons which are going to flow. N is the number of electrons. So electrons जो है E का value over here is minus 1.6 into 10 raised to minus 19 coulomb. So that is the charge per electron. Okay, charge on one electron is minus 1.6 into 10 raised to minus 19 coulomb. And accordingly, you will find that the charge, that is this charge is measured in Q, is measured in coulomb. So that is the coulomb over here. So that is the unit of charge. So accordingly, we see the charge is N into E, that is number of electrons. And the current, we can see current is given as I and the current is given as Q upon T. So accordingly, it will be NE upon T. So this is the thing about the current. And current, you know, this is nothing but the charge is measured in coulomb and the time is in seconds. So that's why current is coulomb per second, which is also equal to 1 ampere. Okay, so it is the unit of current is ampere. So electric current as rate of flow of electric charge. We have read that when two bodies are rubbed together, they get charged due to the transfer of electrons from one body to the other. The body gaining electrons become negatively charged, while the body losing electron gets positively charged. Of course, we have seen that thing. So when it rubs two bodies, of course, one is ऐसे दोनों को body को rub किया, तो one will जिसमें से electrons यहाँ पे इधर जाएंगे, तो this becomes negative charge and this becomes positive charge. A positively charged body has a deficit of electrons, while a negatively charged body has an excess of electrons. The charges can be made to flow between them by suitable arrangement. For example, if two charged bodies are joined by a metallic wire, the electron flows from the body with more electrons to the body having less electrons. So, if I got two bodies, suppose this is body A and this is body B, and suppose this has got 100 electrons and this has got only 10 electrons. So, you will find that if I connect a wire like this, then the 100 electrons will automatically they will pass from here to here till the time that both of them become 55 electrons each. Okay, because the average of this thing is 55. So accordingly 45 from here will go and go here. Accordingly at the end of this reaction, end of this transfer of electrons, both will get same number of electrons. So electrons are going to flow from one body to another body when they are connected to each other by a conducting wire. The flow of electrons constitute an electric current. Thus, current flows due to the motion of charges. Or we can say the rate of flow of charge gives the magnitude of current. That's why we have it rate of change, rate of flow of charge, Q upon T, rate at which the charge flows, that is charge upon time. So, that's why we define current as the current is the rate of flow of charge across the cross section normal to the direction of flow of current. So means whatever is the amount of charge flowing through a cross section of a wire. अगर एक wire है उसका अगर cross section करते हैं तो ये cross section हुआ, तो वो cross section में with respect to time what is the rate of flow of the electrons is nothing, or charge is nothing but the current. If charge Q flows to the cross section of the conductor in time t, then current I is equals to charge Q upon time t. The current is a scalar quantity. Yes, current is scalar quantity. It does not require any direction to be there. When I say 5 amperes, I don't need to express it in any kind of direction. It is always unidirectional. In metals or conductors, current flows due to the movement of electrons, while electrolytes, current flows due to the movement of both the positive and negative ions. An electron carries a negative charge equal to minus E, where E is 1.6 into 10 raised to minus 19 coulomb is the electronic charge. If n electrons pass through the cross section of the conductor in time t, then the total charge passed Q is equals to n into E. The total charge which is passing through the circuit through a particular conductor is n into E. And the current in the conductor is equals to I is equals to Q upon T is equals to NE upon T. So that's what they have said, that when you are going to have a current carrying conductor, so it will always be that the metals, in metals, when there is going to be current flowing, it will be possible for the current to flow through it because of the free electrons present in the current. So if this will be a metal, then the flow of electrons over here will be due to the free electrons which are present in this conductor. Okay, the free electrons is making the flow of current possible. But if it is an electrolyte, that is in case of a battery and all, at that time it is the ions, that is, suppose there is sodium chloride inside. So Na plus is going to go from the electrolyte to the cathode and Cl minus is going to go towards the anode. So the ions of positive and the negative ions, the positive and negative ions present in the electrolyte are going to cause the flow of the current. So the current is going to flow in two ways. In case of conductors, it is going to go through the free electrons present in them, and in case of electrolytes, it is going to take place due to the cations and anions present in the electrolyte. The movement of the cations and anions are going to cause the movement of the flow of electrons, flow of the current, sorry. Note, in an electrolyte, the current flows due to the movement of both the positive ions, cations, and negatively ions, anions. In 1 second, if N1 positive ions each carry of charge Q1 move in one direction and N2 negative ions each carrying a charge of Q2 move in opposite direction, the total current will be I is equals to N1 Q1 plus N minus N2 minus Q2. So it will be N1 Q1 plus N2 Q2. Because the direction of current is taken positive in the direction of the flow of positive ions and negative in the direction of the flow of negative ions. So when you are having the flow of positive ions, so basically positive ions are going to go in one direction, negative ions are going to go in another direction. So QK, negative ions have got negative charge, so negative ions minus negative, negative positive ho jayega, minus minus plus. That's why the total current will be the charge moving from one end to positive and one end to negative. So isliye the total charge will be equal to the sum of the multiplication of N into Q1 and N into Q2. Now direction of current, conventional and electronic. Now there is something very important and also slightly confusing also. Conventionally, so if I got a circuit, or let's say this only. Now I told you that the electrons are going to flow from A to B. The electrons are going to flow from A to B. But it will be seen that when I am talking about the current will be flowing from B to A. So conventionally, the flow of the current is opposite to the flow of electrons. Okay, flow of current is opposite to the flow of electrons. So if I say the current is going from B to A, that means that the electrons are actually moving from A to B. Now why is it so? Is because A has got more negative charge. So that's why this has got lesser potential. This is more negative and this is more positive. Because it is more negative, this is more positive, that's why हम लोग always positive को ज़्यादा value देते हैं. इसलिए this is at higher potential. Whereas this is a lower potential. Why? Because it got more negative charge. And that is why we always see that the current is going to move from higher potential to lower potential. So current moves from B to A, but actually move क्या हो रहा है? It is the electrons which are moving. And electrons क्या है? They are higher over here and lower over here. So the electrons move from higher electrons to lower electrons. So that's why the movement of electrons is opposite to the movement of the current. So you can just remember this thing this way, that the conventionally, so you can conventionally the direction of current is taken positive in the direction of flow of positive charge. Now flow of positive charge, is there any possibility for the protons to travel? No, the protons are never going to travel. So flow of positive charge to hoga hi nahi, but it is basically positive charge यानी क्या? Electrons का opposite. Therefore, conventionally the current will be negative in the direction of flow of electrons. The rate of flow of electrons in the direction is called the electronic current in that direction. So the rate at which the flow of direction is going to be taken care of, the rate of flow of electrons in that direction is called as the electronic current in that direction. The conventional current or simply current is in the direction opposite to the direction of motion of the electrons. The magnitude of conventional current is the rate of flow of total charge across the given cross section. So yeah, the magnitude is going to be the same, but the point is that the direction of the current and the direction of electrons are opposite. Unit of current. From relation I is equal to Q upon T, unit of current, unit of charge upon unit of time. If SI unit of charge is coulomb and SI unit of time is second, so the SI unit of current is coulomb per second. That's what I explained to you, coulomb per second, which is nothing but ampere, which is called as ampere. It is denoted by symbol A. Thus 1 ampere is equal to 1 coulomb upon 1 second. So 1 coulomb upon 1 second is equal to 1 ampere, or we can define that thus current is 1 ampere if the rate of flow of charge is 1 coulomb per second. So since 1 coulomb of charge is carried by 1 upon 1.6 into 10 raised to minus 19, that is equal to 6.25 into 10 raised to 18 electrons. So we can see over here that this is the charge. So I know here that 1 coulomb is equal to N, that is equal to, okay, we'll take it N into 1.6 into 10 raised to minus 19. So N का value क्या मिलेगा? 1 upon 1.6 into 10 raised to minus 19, which is nothing but equal to 6.25 into 10 raised to 18 electrons. So we can see that when is 1 coulomb charge flowing? When 6.25 into 10 raised to 18 electrons travel from one end to another end of a conductor in 1 second. So that's why if a 1 ampere current flows through a conductor, it means 6.25 into 10 raised to 18 electrons pass in 1 second across the cross section of conductor. Note, weak current is measured in the unit milliampere, MA, or microampere, mu A, where milliampere is 10 raised to minus 3 ampere and microampere is 10 raised to minus 6 ampere. So that was about the current part. Now we see certain symbols which are used during the circuit diagram formations. Okay, so let's go by one in the next video.